And before break, we covered some of the easier questions out of 1.3. Now we're going to look at some of the more complicated ones. These, though, you have seen before. In your previous classes, you have done the mixture, the investment, and the distance problems. And that's what we're going to be looking at today. On these, we make a table. We then look at a total, kind of like what we did up here. And then we solve it and we get our solution. So let's look at question 53. And this is going to be on page 90. And we're going to look at question 53. So these we're going to read through. We're going to draw a picture or diagram and come up with our equation and solve it. Michelle invested some money at 4.5% simple interest and 1,000 less than twice this amount at 3%. Her total annual income from interest was $1,020. How much was invested at each rate? Now let's think about this in terms of a savings account. If you have a savings account at the bank and you get your quarterly or your yearly statement, what does it have on there? Okay, on that statement, it's going to have how much money's in that account, right? It's going to have what percentage it pays out, maybe 1 or 2% or even less than that. And then it's going to be how much interest that you made during that quarter or that year. So you've got an amount, a percentage rate, and then the amount of money it made in interest. So total amount, money earned, and interest rate. What we're going to look at on these is we're going to find, or we're going to be given the amount and the percentage rate, and then we're going to use those to calculate the interest earned, the amount of money that you made in interest. So when we talk about amounts here, this is how much money we have in these accounts. And then over here we have a total. And I'll just call this 1, 2. And then we add together to give you the third one. So we're really going to take our time and really try to figure out what pieces go where. Michelle invested some money at 4.5%. So this is going to be the first account. Now, does it tell me how much money is in that first account? No. So that is going to be represented by the X. It does give me a percentage rate. And what's my percentage rate? 4.5%. So that's my first account. That's the first piece. And 1,000 less than twice this amount. So 1,000 less than twice this amount. That would be 2x minus 1,000, right? 1,000 less, that means we have to take it away from twice that amount. And what is my second percentage here? My second percentage is 3%. And we go ahead and find our total just by adding across. We don't need it, but I find it so you don't get confused and put something else there. So when we add these across, 1 plus 2 is 3. We don't worry about our percentage rates. We just add our amounts across. So if I add across, that's 3x minus 1,000. In some questions, you may have a total amount, and we may have to work with it. Now we've got it all labeled out. Now we need to look at our interest. And the interest is going to be the amount times the rate. First fund. Okay, interest is the amount times the rate. And we have to convert these percentages to a decimal. So our amount is X on the first one, and the percentage rate is a decimal, is 0.045. So that's going to be 0.045 times the X, right? Amount times the rate. And I just put the rate front. Now we move on to the second one. What's in the second one here? 3%, so that's 0.03. And how much is my amount now? 2x minus 1,000. And what is on the right-hand side? This is the total amount. Okay, so that when I talk about the total, this is the total amount of money that I have. When I talk about it down here, this is the interest earned, or the money made. So how much money did we make? Yep, 1,020 or 1,020. So that's how much money I earned. Now we can solve it out. So we drew our diagrams up here with the amount and the rate, and then we have to calculate out the interest. That's where we get our equation, and then we can solve it from here. So now we just distribute through. And just be very, very careful with the decimals. So we have a 0.045x plus, we multiply through 0.06x. And then we've got 30, I believe, isn't it? Because 1,000 times 0.03, that's going to be a 30. It's a minus, so it's going to be minus 30. And that equals your 1,020. And go ahead and combine. Now again, be very, very careful with the decimals. You need to use a calculator, use a calculator. Just do not make a mistake with these decimals. So that's 0.045 plus 0.06. Add them together. That comes out to be 0.105x there. Just take your time with the decimals because you don't want to make a mistake and miss the problem because you weren't careful with the decimal. So now we just add our 30 over. And we've got 0.105x equals now 1050. We divide by 0.105. And that leaves us with x. And that should come out to be 10,000. We're not done yet though, because it wants the amount in both accounts. So in our first account, account number 1, how much is in there? Okay, this goes back to the 1 here. The first account is 1, and that's X. So we've got $10,000 at that 4.5% interest. Our second account, what is it? 2x minus 1,000, right? So that's going to be 2 times 1,000, or sorry, 10,000. Say it correctly here. Minus 1,000, and that gives you then 19,000, and that is at 3%. And that's what we wanted. We wanted to know how much was in each account. So one account has $10,000, and one account has $19,000. And I know that students always struggle with the setup on these. These and the mixture problems are the more difficult ones. We'll look at the investment ones in the next section next week. These are the two types we're going to look at today, investment and mixture. So that's an investment. Let's do another investment one. $56. So Mona received a bonus of $17,000 from her company, and she invested it in an account paying 6.5%. How much additional money should she add in an account that pays 5% so that the total return on the two investments would be 6%? And you've got for each of these, remember, an amount and also a percentage rate. So she starts off with the bonus of $17,000. And that's going to be your first one, first account, so $17,000. And that's going to be at a percentage rate of 6.5%. Is everyone all right with that so far? Okay. Now we're going to add on some additional money. Does it tell us how much additional money that we have? No. Okay. Nowhere does it give us the additional money, so that's going to be X. This is the additional money. And that additional money doesn't make the same amount of interest. It only makes 5%. Now, when we put these investments together, we want to make sure that we get 6% out. So the 6% is going to go over here. And how much total money do I have? We add across, and that's going to be $17,000 plus X. So let's take a moment to really digest what we've got here. So Mona got $17,000 in a bonus, and she put that bonus in an account that pays 6.5%. She wants to add in some additional money. When we add in additional money, we don't know anything about it, so we use an X here. And that money only pays 5%. Now, we know when we put these together, we want to get 6% out. So this is what you get out over here. This is the end result. We want that end result to be 6%. And how do I find my total amount? Total amount, we just simply add across. We add it across here. Now we find our interest, just like the last one. And the interest is the amount times the percentage rate. And 1 plus 2 is 3. That's how I remember it. So on the first one, amount times percentage rate. So we've got 17,000 times 6.5% as a decimal, 0.065. Be very, very careful with those percentages. The second account, it pays 5%, so that's 0.05. Unknown amount X comes down. And then on our third one, third one is 6%, so that's 0.06. And how much is in there? 17,000 plus X. And this is 3 over here. Because 1 plus 2 equals 3. Now we can just simply multiply. 17,000 times your 6.5%. That's 1105 here. Plus 0.05x. On the right-hand side, we distribute through. And that's 17,000 times 0.06. And that comes out to be 1020 plus 0.06x. Now we can solve it out pretty easily. Again, just be very, very careful with those decimals. So let's move over to 0.06x. And also take off that 1105. So go ahead and subtract those out. So watch your subtractions here. It's going to be a negative because 0.06 is bigger. So that's going to be 0.01x, right? And it's going to be negative here, so make sure you're careful with that. On the other side, we've got 1020 minus 1105. That comes out to be a minus 85. Divide by our minus 0.01. And we know that a negative divided by another negative makes it a positive. So then that comes out to be 85 divided by 0.01. And it looks like that's going to be 8,500. So that's what we wanted to find. We wanted to find the amount. So how much additional money do we need to add in? We need to add in $8,500 at that 5%. If I add that in, then that's going to give me that average rate of return to be 6%. Is it kind of making sense how we set these up? Now, the investment problems are done the same way. And next week, when we look at the distance problems, they are done the same way. So we did 2 investment. We're now going to look at 2 mixture problems. 59 on the next page. The only difference between a mixture problem and an investment problem is the labeling. They make tables, but I think the tables are a little bit confusing. So I like the pictures. I think they're a little bit easier to work with. In a chemistry class, 12 liters of a 12% alcohol solution must be mixed with a 20% solution to get a 14% solution. How many liters of the 20% solution are needed? Okay, so pretty much the same. The only difference is, instead of using dollar signs, I'm going to use little containers to represent the chemicals. Each of these containers has an amount and a percentage rate. 1, 2, add together to give you 3. And this over here is what we want at the end. They have an amount, just like the money problems did, and they have a percentage rate, just like the money problems did. Except instead of it being amount of money, we've got liters or milliliters or gallons, whatever it might be, to mix together. So in a chemistry class, 12 liters of a 12% solution. So that's going to be my first container, 12 liters, 12%. Is everyone okay with that? Just break it up into small pieces. 12 liters, 12%. We are going to mix that with a 20% solution. Does it tell us how much of the 20% solution that we have? No, that's going to be the unknown, so we're going to use the X. Percentage rate over here is 20%. Now, what do we always do? We add across. So when you add across, that gives you 12 plus X when we add across. And what percent do we want? When we mix these together, we want to make sure that we get a 14% solution. It says obtain, that means what we want. We want to obtain a 14%. So that goes over here. Is everyone okay with that? Everything's almost exactly the same. Now the only difference is, instead of using interest, we use the term pure. Your pure is going to be the amount times the percentage rate. And what the pure would be is if we had something like salt water. Okay, if we have salt water, there's a percentage salt in it. If you boil all the water out, what's left over? The salt, that's the pure. Okay, so that's going to be what's left over once you take the water out. That is the amount times the rate. Exactly the same as interest. Amount times the rate. No different. So on our first one, what do we have? 12 at 12%. So that's 12 times the percentage rate of 12, which is 0.12. The next one. These are your pures here. The next one is 20%, so that's 0.2. Right, that represents your 20%. Unknown amount, X. Third container, on the right-hand side, 14%. That's 0.14. How much is in there? 12 plus X. Right? Now we've got it. Now we've got our equation. Work it through. We'll get our answer. Okay, so we've got 12 times your 12%. That comes out to be 1.44. And then we've got 0.2x. And then we're going to distribute this 0.143. So 0.14, we're going to multiply that by 12, and that gives you 1.68 plus 0.14x. Now we've got it, we can solve the equation, and we can get our answer. So move things around. So move over that 0.14x. Now be very careful, again, with the decimals. If there's a mistake, it'll be in the decimals. And then you can also move over that 1.44. If you need to, use a calculator. I'm going to use a calculator so you can see how these decimals go together. So 0.2 minus 0.14. Be very careful and make sure you type them in correctly. That comes out to be 0.06x. And then on the right-hand side, what do we have? We have 1.68. We're going to take away 1.44. I typed it in wrong. 1.68, I forgot the decimal, minus 1.44. And that gives you now a 0.24. Okay, just be very, very careful with these decimals. It's so easy to make a mistake. Divide by 0.24. 0.06, and that gives you then, when you divide, an answer now of 4, doesn't it? We're going to divide, and that's going to give me my answer of 4. So what is that? Okay, let's make sure we label it with the correct units. We are looking at liters for the amount. So we have 4 liters at, our X is up here at the 20%. So 4 liters at 20%. Let's do at least one more, probably. If we have time, 2 of these. We'll at least do one more. Question. Let's look at 62. This one's actually a little bit easier. Okay, so question 62 is what we're going to look at next. And what we're trying to do in this question is we're going to try and reduce down our insecticide solution. Maybe it's too strong. Maybe there's one solution for the inside of the house and one solution for the outside. And we have to dilute one to get the other one. So it says how much water must be added to 6 gallons of a 4% insecticide solution to reduce it down to 3%. And it gives you a hint that water is 0% insecticide. Okay, so we're going to do the exact same process again. We're going to have our containers. One, 2, and 3 here. And the first one's going to be water. So it says, how much water? When we talk about water, should there be any insecticide in water?
No.
No. So what should the percentage of insecticide be in this tap water? 0. So that's why it's 0. Now, if this was pure insecticide, then it would be 100%. So right now it's 0%. It's water right out of the tap. There is no insecticide in it. Then I'm going to take that water and I'm going to use it to dilute down 6 gallons of a 4% solution. So this is the insecticide over here that we have. This is what we've got on hand. It's right over here. We've got 6 gallons at 4%. And this is what we want at the end for box 3. So we always add across. So that's going to be X plus 6 here. This is my total. This is what we want. And we want to reduce it down to 3%. So we want to go ahead and just reduce it down so that we can, without having to have 2 containers, we can go ahead and just do the outside of the house. So we take what we've got with the 4%, we reduce it down a bit with some water to get 3%. We need to find our pure. Pure is always the amount times the percentage rate as a decimal. So when we talk about water, that's 0 times X, right? That's your water. When we talk about box number 2, that's 0.04 times the 6 gallons there, right? Amount times the rate. And then what does that equal? That equals box 3, because 1 plus 2 gives you 3. That's how I remember it. That is 0.03 times X plus 6. Now this one's actually a little bit easier because that water, there's no pure in the water, so it's gone. Right? No insecticide in the water, so that piece is just gone. So what are we left with now? Well, we are now left with, when we multiply through, let's go ahead and use our calculator here. We've got 6 times 0.04, and that's going to be a 0.24 here. And then on the other side, we're going to distribute through, like we always do. And that's going to be 0.03x. And then I believe that's 0.18. But let's double check and make sure. You really don't want to make a mistake. That's 0.18. Now we have something that's very easy to solve. So I'm going to move that 0.18 over. And I'm just going to write the 0.03 on the left just to make it a little bit easier. And we've got 0.24 minus 0.18 on the right. And that comes out to be 0.06. Divide. And what does that now give me? I believe that's 2, isn't it? Yep, let's double check. Yep, that comes out to be 2. So we need 2 gallons of water. That's your x. Okay, so that's your 2. So you now have, or you need 2 gallons of water. So when you're finished with the outside of the house, if you want to go spray the inside of the house, you can just take the container that you've got. It's got the 6 gallons. Add 2 gallons of water to that. You get your 3 gallons, or sorry, not 3 gallons, the 8 gallons total, and then you can go out and spray the inside of the house. But all you need to do then is add 2 gallons of water to what you've already got. Let's do one more. And this one is just going to be mixing different types of teas together. So 64. This will be the last question we're going to look at. It's set up the same way. It's just a little bit different in the labeling. Again, they give you a table. I like to draw diagrams. I think they're easier. So Leanne wants to mix tea that is worth 2 cents an ounce with 100 ounces of tea that's worth 5 cents an ounce to make a mixture that is worth 3 cents an ounce. How much of the 2-cent tea should be used? Okay, so containers again. And we're going to have the amount, and instead of a rate, we're going to use a cost. Okay, so Leanne wants to mix tea that is worth 2 cents an ounce. Well, we don't know how much tea we need, so we use the X there, and that tea costs 2 cents an ounce. So there's that. Now, what about the next one? What are we going to do? We're going to mix that with 100 ounces of tea that costs 5 cents an ounce. And we add across again, so that's X plus 100. And then what do we want? Remember, box number 3 is what we want. We want to get out tea that sells for 3 cents an ounce. Now, instead of having it pure, we're going to use the total cost. And the total cost is going to be the amount times the cost of the t. No different, just a little bit different on the labeling. That's the only difference, is just the labeling. So our first container, unknown amount of t, 2 cents an ounce. So that's going to be 0.02 for 2 cents times the x. Second container of t, 100 ounces, 5 cents an ounce. So that's 0.05 times 100. And that equals the other side, which is 3 cents, which is 0.03. And that's x plus 100. Now we can finish it. We just multiply. So that's 0.02x. We've got 100 times 5 cents. That should be 5, I believe. Yep, that's going to come out to be 5 there. That equals then, when we distribute, 0.03x. And then that comes out to be plus 3. Now we can solve it. We just move things around. So let's move over that 0.03x. And move the 5 over as well. And that leaves you with then a minus 0.01x. And that equals a minus 2. Now we can solve it. And I am going to look through at least one of these questions from your homework as well. Okay, we'll look at, I'll help you set up one of these before these. So we'll finish this one out, and then I'm going to set up one from your homework. We'll divide by our minus 0.01. Negative and negative makes it then a positive. So x should come out to be what? 20, I believe, or is it 200? Let's see, 2 divided by 0.01. That comes out to be 200. So what do we need? We need 200 ounces. That costs 2 cents per ounce.
Can you move the paper up?
Yep, sorry about that.
No, you're okay.
Yep, so I'll give you a minute to get this copy down here. And then we're going to talk about question 17. I'm not going to work out question 17 completely, but I am going to explain how to set it up and get you to the equation. Now, next week when you have questions, I am not going to solve them completely out. What I will do if you have a question on a problem is I will get you to the equation part. Because if you have a lot of questions, we just won't have time to do each one. And where students usually struggle is just in the setup. So we're going to look at question 17 on your homework. I'm going to set it up. I'm not going to solve it. Okay, so this is going to be question 17. And this one is a little bit different. That's why I'm going to set this one up for you. But you're going to have to solve it. Question 17. It is necessary to have a 40% antifreeze solution in the radiator of a certain car. The radiator now has 40 liters of a 20% solution. How many liters of this should be drained and replaced with 100% antifreeze to get the desired strength? So we're going to label our boxes again. 1, 2, and 3. This is where we're going to start. This is the pure here, pure antifreeze, and this is where we end up at. We have an amount, and we have a rate for each of these. And this one is kind of confusing because the parts are in a little bit of a different order. When I read this question, it says, it is necessary to have a 40% antifreeze solution. So when I talk about that 40% is what I want at the very end. So when I'm done working on the car, that car had better have 40%. So that's why that 40% is going in box 3. The radiator now has 40 liters of a 20% solution. So that's right here. So that's what it starts with. Now, we can't just add more, because if we add more, it's going to overflow. Because at the end, we can only have 40 liters in this radiator. So what's happening is, let's say the person's been driving the car and it has a leak, and so they constantly just add water instead of putting antifreeze in. So they constantly add water, and now it's low on its percentage, but it's full. So we're going to take some of this out, and we're going to replace it with pure, but the car can only hold 40 liters to begin with. So whatever I add in, I have to subtract off. So I'm going to have to drain some of it out. And when I drain it out, it's a negative. So I've got my car. The car comes in with 40 liters in it. It better leave with 40. So I'm going to have to take out some of it. So I'm going to drain out some of it. And however much I drain out, I replace back with the pure. The best example of this that I can come up with is, let's say you're making iced tea. Okay, so you make iced tea. You want it to be a sweet tea. So you've got your iced tea. Now, it's full. If I want to add a cup of sugar, I can't just add a cup of sugar. It's going to overflow, right? So if I want to add a cup of sugar, what do? I open up the bottom and I take out a cup of tea. That way I can put in a cup of sugar and it stays the same level. So that's what I'm doing here. The car comes in with 40. I take an unknown amount out. I replace that unknown amount with pure, and that still leaves me with 40. Because a positive x and a negative x, those cancel. Now, let's get our equation, and you can solve it on your own. So let's now talk about the pure. Again, pure is the amount times the rate. So the first one is 0.2. 20% is a decimal. And how much is in there? 40 minus x, right? Second container. 100% is 1. How much is in there? Unknown amount x. End result. Third container. How much is in there? 40. What percentage rate does it have? 40%. So that's 0.4. You can finish it from here. Now, what's your homework for next week? Well, there's not a lot, because these sections take a long time to go through, because these are the fundamental sections that you're going to need for college algebra. So we have to make sure that we know how to do these first few sections in our textbook So we only did one section today, and that was 1.3. So homework is going to be 1.3, and you can do them all. If you have questions, we can work through them next week. Now, next week, I'm not going to solve the equations on these, but I will set them up. So if you need me to set some of them up, I'll set them up, but I'm not going to work them completely out. I will see everyone next week then. And again, check in Canvas if you want to download the notes or watch the video.